So welcome to our talk, PODfidential computing. So you heard the session about confidential containers and what's going on there in the open source community. We wanted to give you a little bit of backstory, what our journey has been so far into confidential computing and where we are going next. So a little timeline. So 6 years ago, we started to go into the realm of confidential computing without even knowing the term by the time. And our first experience was rooted in a very vertical scenario-specific application when we rolled our blockchain network into the IBM public cloud and allowed our customers to experience blockchains for the first time and play around with hyperledgers. We wanted to create a pretty clear isolation between administrators of the environment in our cloud ecosystem and the sensitive data that customers are running within their clouds. And so we used a capability called secure service container. So that was the inception point to go GA in the public cloud with the first service that we are running. Since then, we actually moved ahead quite a bit. So we have extended the services and have generalized them. So instead of just putting it into an industry vertical or into a solution vertical, we built a platform, and in that platform allow our clients and partners to build a complete end-to-end solution with confidential computing at its core. So the technology base that we're using is actually twofold. So we are using Intel SGX mostly for wrapped physical abstraction layer kind of containers where we are working with the software from Fortanix. In our solution, it's called Data Shield. So it's wrapping around or auto-wrapping containers. You can also natively code against it in the cloud, but for the most part, we're using that for container workloads today. And then we've got a second pillar where we built our technology leveraging our mainframe technology platform with IBM Z and Linux One that has a very strong isolation boundary at its heart. It has a hardware security module, so it has a lot of enterprise-ready compute capabilities that allowed us to implement confidential computing on top of that. So using the hardware and firmware-driven isolation that was in the box. So everything in green circles that you see here on the slide is provided by our own IBM-owned technology, and everything that you see in blue is coming from Intel SGX or is based on Intel SGX. So we're experiencing both, and we keep evolving on both fronts actually with the different technologies around. When we talk about confidential computing, there's on one hand the different compute layer, right? There's containers, there's VMs, there's databases that we are running, and we've got underpinning all of that a key management system. We're also putting a focus on communication in and out of the cloud. So we are protecting TLS session negotiations with hardware security modules to make sure when you're connecting to the cloud property from the outside somehow that you know that you're at a valid endpoint. So it's not enough to steal a server certificate to create a man in the middle. You can't do that in our case because you have to actually be physically connected to the HSM in order to do that. Beyond the runtime capabilities, there's another capability you see here that's called secure build service. So we're also allowing our customers to build reliable, auditable images in the cloud ecosystem that are then forming the compute base and are implementing the workloads that they're running within this ecosystem as they go through the different stages within it. So let's look into various customer scenarios and what customers have done. Since we are in that, as I mentioned before, for quite a while, we have seen many customers coming. And the first wave that reached out to us was the kind of clients that you expected. So regulated industries from financial services who were interested in running and securing workloads in the cloud to an equivalent layer that they were doing on-prem. So regulations, data protection, and enforcement of transaction integrity were elements that were driving in there. Soon, with the financial services, there was the next wave coming in with the digital assets, as the industry there is undergoing a little bit transformation and more digital custody services, digital wallets, digital blockchains are coming in. So came the partners and startup smaller companies that are going in and are very nimbly and agilely conquering the world there. Banking and payments, there's the small micropayment element also as well. That made very early use of confidential compute technology. So Irene Energy, for example, is protecting micropayments for energy consumption for people who don't have a bank account to pay. They can do that right straight from their mobile phones that they're charging at the same time they pay for that. But also larger scale transactions like a Temenos, which would do banking payment transaction in the background. There's a whole slew of AI applications, and I'll talk about that in the middle. Look into the others first. There's an Apple CareKit integration that we've built around to build end-to-end security from the enclaves in the device to the enclaves running in the cloud and connecting all the way in between that, leveraging the end-to-end platform in between. And we've got customers who are very focused on securing their own data, their differentiation, their intellectual property within it, and that we're working with. So Spectrum has been brought within the first 2 years when we're in that endeavor, and it's exploding these days right now. So when you see how many people are jumping on and doing things, it's an incredibly exciting time. So conferences like OC3, I think, are helping to get the word out what the technology can do, and I'm glad to have you all here. So let's look a little bit deeper into the scenario that I skipped before. So with that federated AI, a pretty cool example of using confidential computing to provide a differentiated service. So it's not only providing something that you could do before, just at a more secure, better protected, better isolated way, actually allowing a use case that was not thinkable, not possible, not doable before. So we are working with a set of industry organizations together who are jointly buddying up and collaborating together to fight organized crime, where organized teams are actually going off and commit a large set of smaller crimes where each individual small crime doesn't hurt, doesn't harm anyone too much. But when you combine them all up, it actually becomes a larger ecosystem of crimes that's happening. So when you can identify that there is an organized group behind it, you can identify the crimes that they committed, now that becomes worthwhile to pursuing and going after. But these organizations, for competitive reasons, didn't want to share data with each other, or for regulatory reasons, weren't able to share data with each other. So what we did is we allowed them to do their data loading, data analysis, learning, and combining from that in the confidential compute platform, but then sharing the insights and the identification with it, and then they get their own insights back, which of the specific cases were born to a larger case that they should be reporting in. Exciting stuff, use cases that were not thinkable without confidential computing, but these days are really possible, and we're starting to implement more of those. So let's look a little bit deeper into the technology that is running underneath it. So the first element that I mentioned is our key management component. We call it HyperProtect Crypto Services. So it provides crypto functions as well as key management solutions. And for the most part, when it's managing keys, it's keys for other services. So we're encrypting data in our cloud object storage or in block storage and databases along the way with it. Runtime components, HashiCorp Vault can lock its lockbox together with the crypto keys, or we're using that for VMware-based workloads, Kubernetes service. So a pretty broad set of services that are integrating vertically on top of the key management component. But also, if an application wanted to, you can go to lower level APIs like a Java crypto architecture or JCA or PKCS11. It's right there provided within the service. So let's look a little bit further. When we implemented that service, one key component, we wanted to ensure that our customers have exclusive control over their keys. It could be because of regulatory compliance reasons that they needed to have this exclusive control, or it could be because of sensitivity reasons that they had. So we implemented a single tenant instance-based service where for each tenant we are instantiating a new instance in the environment. The environment is completely locked from administrator access and anything. So it's using confidential compute to lock down the processes that are running for the clients, and then tie that closely into a pretty good certified HSM that we have, which is allowing any physical attack will automatically wipe out keys. So keys you put into that system can never be exfiltrated, not by runtime access, nor by physical access, which then provides a new way of protection that we do. So the next service I want to briefly mention before I hand it over to James is our database service. So when we talk about protecting databases, you can decompose databases all day long and create interesting scenarios where you're encrypting parts of the data, but then when you look at it, you quickly decrypt it and do filtering on it. But it fundamentally means you have to change the architecture and the implementation of the database. We figured there's a more efficient way to allow the database to behave exactly the same way, abstract complexity of confidential computing away from the database user. So we isolated and are running entire databases within our enclave technology. Due to the fact that we do have very well performing IO intense applications on our platform, we can do that with incredibly speed and still run the entire database in an enclave. And actually, when I say one enclave, one more slide, and then I'll give it over to James. When I say enclave, actually it's 3 enclaves that in that concert are working together. They're distributed across 3 availability zones, which make up a multi-zone region. There's failover replication. In this case, it's Postgres that is replicating in between. There's a primary, 2 secondaries that are running. They're all active, as it can be accessed in the environment. External traffic is routed into them, but it's 3 enclave collaborating and working together and isolating all the data, database logs, and everything is exclusively controlled within the enclave, while still the service itself and availability of the service can be managed within the infrastructure. But now I don't want to steal more time. Give it all to you, James.
Thanks, Stefan. So I guess looking at today and beyond, so today on the Linux One, we have our own trusted execution environment, as I guess is the whole point of today's conference. One distinct difference, I guess, between our approach and others perhaps is that the actual guest image is encrypted, and the key to decrypt that is stored in the microcode and unique potentially to the physical system. So that's just a minor difference, I think. But essentially, as we've heard earlier from Mark and Moritz and others, that the trusted execution environment and what we're trying to achieve with it is exactly the same. It's protecting the data in use from the host and from anyone outside the trusted execution environment. So I think we've had a lot of explanation about trusted execution environments and confidential computing. So I won't dwell too much on this slide, but we have got a Q&A after anyone is interested in more of the technical details around what we have for secure execution on Linux One. But what I'll move on to is kind of where our process of thinking started and why we ended up on what we're calling here is confidential computing is the kind of the title of what we got here. So if we imagine that we have this dashed red boundary here, and that's our trust execution environment, and into that we put our application and our data. We think, great, that's excellent. We've protected the important parts of what we want to protect. We've protected our data in use, and if there's anything that's needs protection in terms of our code or our application, hey, that's protected as well. Obviously, there's a whole chain that goes into SecDevOps and delivering that, but fundamentally, the application owner is in control of what crosses that boundary. But now, as we move towards orchestrating that, and as Moritz highlighted, the world of cloud native and Kubernetes, new concepts come into existence. And the problem here is that it's not sufficient for us to think that the only thing that crosses that trusted execution boundary is the application APIs or whatever the application offers. We now have to consider what orchestration actions also cross that boundary. And so we're not actually, unless we're careful here, in total control of what's actually crossing our boundary. We have to enable the orchestration environment in which we're living, such as Kubernetes, to be able to do what it needs to do. Otherwise, we lose the benefits of orchestration. So when we started to think about this, we obviously want to have a cloud native confidential computing experience. And as it's been sort of explored before, there are various places where you can put that boundary that the trusted execution environment offers you. You can put it around the node as Moritz highlighted, and as we've heard about processes, we can put them around, SGX being an example of that sort of approach. Where we were coming from was we wanted to consider 2 personas, and those personas being the workload provider. They're, in a Kubernetes sense, the ones that would define the pod descriptor, the workload that's got to run, the resource requirements it has. And we think about this as different to the administration of the Kubernetes environment. So yes, the Kubernetes admin would deploy the pod, but the definition of which containers are needed for a solution, how they fit together, comes from that workload provider. And so in this world, if we were to put the trusted execution boundary around the node, well, the Kubernetes admin is already inside that environment. And so that limits us. But our goal here was focused on this workload provider, this pod descriptor. How can we offer a confidential computing experience, but not change how the workload provider sees the world? Not change what they have to define in order for their pod in a Kubernetes sense to be deployed. So in the wheel in the bottom left here, we're trying to balance the security that we can offer with confidential computing, obviously set against performance in all of these things, but in an acceptable way of using Kubernetes. So we want to offer as little difference from the experience of how you deploy a workload. So it becomes a deployment decision, not a build decision or a test decision as well. It's a case of you can deploy exactly the same thing, and you choose if you wish to deploy that into a confidential computing or a trusted execution environment, or if you choose to deploy that for test or whatever purposes anywhere else. And it should behave the same. It's just the security proposition that's different. But where we kind of started to explore differently is when we think about this world, we have challenges in this world, because if we think about it today, a lot of the, or most of the trusted execution environments that we have are kind of offered in the top of a bare metal experience. But as bare metal becomes larger in terms of resources available to it, then perhaps the expense or the cost of an entire bare metal system for the confidential pods that you wish to run becomes something that isn't ideal for your world, especially when you consider that the whole point of having something like a Kubernetes cluster and having the orchestration is to have multiple Kubernetes nodes for failover, to have them in multiple data centers for failover. So we're not just looking at one bare metal node in which to run our confidential containers. We're essentially looking at multiple of those nodes spread geographically, perhaps distributed as well, for us to see the full advantage of having Kubernetes orchestrate and keep these things running. So really on the right-hand side is an ideal world. If we could have nested virtualization and still be able to exploit these trusted execution environments, well, that gets us kind of the best of both worlds. We can have the trusted execution environment. We don't have to pay or have the expense of an entire bare metal node in order to exploit that. But we aren't quite in that world on the right. So where we started to explore is this world in the middle. And part of the technology that we're building on is that Samuel talked about, this confidential containers project and initiative that we're a key part of, became a premise for what we needed to do here. In order to have this work, we were launching what we call peer pods as peers to our Kubernetes nodes. And the way we can do this is by using cloud APIs today in order to deliver this. But part of the premise here is that a lot of the control and responsibility for what happens needs to be instigated from within inside the pod. So at this point, if we enter a world where the node is not facilitating the delivery of containers, is not facilitating the storage to the pod, well, we're entering a world where that pod could actually be distinctly separate. It could become a peer. And there are advantages that we can start to exploit or see in that, because if the pod is a peer VM, it can have different SLAs. It can have the storage attached directly to it. So there are a lot of security advantages or performance advantages that could be leveraged. Equally, we appreciate there's a lot of challenges we have yet to resolve, because modeling this for the Kubernetes admin will exhibit some changes into that environment. But we feel that at the moment, and we've got a prototype of this working as we look to work with the confidential containers community, we've got a prototype of this working where the workload provider doesn't have to have a different view of the world. And I think with that, I've pretty much run out of time, but we are available for questions and answers. And if anyone's interested in this kind of approach, then please join us for Q&A. And with that, thank you very much.